Alright guys, we're starting off with some notes. Don't worry, you don't need to write down every single one of these. For those of you who have a book, it's in your book. But we just want to go over a couple of definitions. And one is a central angle. And so a central angle is a circle where the angle is at the vertex of your x and y axis. So this is your x and y axis, and we just put it at the very center of your circle. And it is formed between the initial side and the terminal side, things that you've already done. So in here, we would call this your central angle. I usually call it theta. The intercepted arc is the distance around the circle between the initial side and the terminal side. And these are both really important because it gets us into a discussion of radians, which I kind of mentioned next week. So you're going to want to make sure you have your blank unit circle. Mine is filled out, but the one that I had for you from last week, I will attach it to this task as well, so in case you didn't have it filled out from before. But a radian is a measure of a central angle that intercepts an arc. So it's an angle, just like if we would have said degrees, but it is when that the arc length is equal to the radius of the circle. So they're showing that here in this picture. And because of that, we have this proportion that's equal to each other. We can say that some amount of degrees over 180 degrees is equal to some amount of radians over pi radians. And this really comes from the fact that it's like a unit conversion. It's the same thing as where we can say, you know, there's 12 inches in 1 foot. It's a unit conversion. We can say that there are pi radians in 180 degrees. So if you ever want to know where pi is, pi, as far as a measurement, would be all the way over here. Excuse the noise in the background. My son does not care that I'm filming, so you can hear his music in the background. So we go from 0 degrees or 0 radians all the way over to pi radians. That was a lot on notes. And all of that is just going to be used in being able to go from angles to radians, or degrees to radians, and radians back to degrees. And so what is the radian measure of a 25-degree angle? So if we're starting with 25 degrees, and these are really what you want to copy down. So let's zoom in a little bit on that. So to convert from degrees to radians, if you're starting with degrees, notice that with your unit conversion, you're going to multiply your pi radians on top. So pi all over 180 degrees. All we're doing here is a unit conversion. It's the same as if I had inches. I had more inches down here in 1 foot. So if I multiply this through, I get 25 pi all over 180. I don't want a decimal. I want a fraction. Notice this is really important. It says fractions only. And I want my most reduced fraction. So right away I can say, well, maybe they both have 5 in common. So 25 divided by 5, we all know, is 5. 180 divided by 5 is 36. So this can be reduced to 5 pi all over 36. And it can't be reduced any farther. That would be the final answer that you want. I don't want decimals. It's different when we go the other way though. It's different when I go from radians to degrees. I have the opportunity of getting a decimal with degrees. I don't think in this case that we will, but if we start out with radians, then we want to go to degrees, then I want to multiply with the degrees on top. So 180 degrees in every pi radians. Notice when I multiply straight across, the pi's cancel out, and I'm left with the 180 over 6. Well, 6 goes into 180 30 times, and so that is 30 degrees. Make sure you guys have this down because the next slide you're going to get a little bit of time to practice. Alright. I really only want you guys to do the top 3. We don't have time for the bottom 3 in this video, so go ahead and just try the top 3. I'm going to pause it while you guys are trying that. All right, so hopefully you had some time to try it. Remember, if I'm going from degrees to radians, I'm going to multiply by pi all over 180. So this becomes 10 pi all over 180, and then hopefully reduced by a factor of 10. So I would get pi all over 18. All right. 3 pi all over 2. If I want to go to degrees, then I'm going to multiply by 180 degrees over pi. Whatever you want has to go on top. If you want degrees, you need degrees on top. So then the pi's cancel out. 3 times 180 is 540 divided by 2, and that all becomes 270 degrees. And last but not least, this negative 35, I can multiply by pi all over 180, giving me negative 35 pi all over 180. If I divide top and bottom by 5, 35 divided by 5 is 7. 180 divided by 5, I believe, is that 36. So we get a negative 7 pi all over 36. All right. Now I hope that you have your units circled. Mine is a little different. So mine looks like this, just so it's easier for me to show you on notes. You guys should have one that looks like this. And notice you already had all the angles in there, and you already had all the values. Then there's a little line where you guys are going to put in your radians as we go around. All right. There's a way I like to do this. I like to divide my circle into 45-degree angles and then 30-degree angles and do some reducing. So that way, because, you know, if you were in school, you'd have to memorize this. That way we can eliminate memorizing. So one thing is, what is 45 degrees in radians? Well, I can try. I can say, what's 45 times pi all over 180. In this case, I get 45 pi all over 180, and .45 actually goes into 180. So if you divide 180 by 45, you get pi over 4, right? So right here for radians, we're going to say that this is really the same as pi over 4. Now, look what happens though if I count around my circle. I have 1 pi over 4. Here's 2 pi over 4. So it's originally 2 pi over 4. That reduces to be what? Pi over 2. So 1 pi over 4, 2 pi over 4. Here's 3 pi over 4. That doesn't need to be reduced at all. And I come down here to 4 pi over 4. Well, you should recognize that 4 pi over 4 is just pi, and we're at 180 degrees, so we know that. I come down here, if this was 4 pi over 4, this is 5 pi over 4. This is going to be 6 pi over 4 down here. But 6 pi over 4 reduces to be 3 pi all over 2. So we learned a couple of things here, that at 90 degrees and 270, they reduce. to have a denominator of 2. So 90 degrees is pi over 2. That's one you're going to hear all the time. So 270, 3 pi over 2, which was really 6 pi over 4. So then we end up here at 7 pi over 4. And then this is 8 pi over 4. And there's two ways I can show that. One is 0 radians. And if I went all the way around, it's also 360 degrees. So it could be as 2 pi as well. All right, I hope that makes sense. So now let's try with 30 degrees. This way we don't have to convert radians every time. A lot of people teach where you go through and you do the radian conversion every time. That takes a lot of time, and I don't know that it adds to your learning. So I'm going to take 30 and I'm going to multiply it by pi all over 180. And we did something similar to this, but 30 goes into 180 6 times, so we end up with pi over 6. So here at 30 degrees, we have pi over 6. So we're going to do it again. We're going to cut it up in a bunch of 30-degree segments. So here's 1 pi over 6. This is another 30 degrees up here at 60. That's 2 pi over 6. Well, 2 pi over 6 reduces to be pi over 3. Then we're up here at 3 pi over 6, which becomes pi over 2. Then we come over here to 4 pi over 6, and that reduces to be 2 pi all over 3. Then we're down here at 5 pi over 6. That one just stays. This is 6 pi over 6, also known as pi. Here's 7 pi over 6. We come over here to 8 pi over 6. But that reduces to be, let's see, 2 goes in there, 4 pi all over 3. And then 8 pi over 6, 9 pi over 6, which down here reduces to be 3 pi over 2. We come over here to 10 pi over 6, and that becomes 5 pi over 3. And then last but not least, 11 pi all over 6. And we have filled in all the radian angles for our unit circle. So if you didn't fill them in as I went along and you just watched, which is just fine, go ahead and pause. You don't necessarily need to put in the, like, if I had to reduce it, like 4 pi over 6 to 2 pi over 3, if it's getting too crowded. But I wanted to show you how you can easily fill out a unit circle just by doing a couple conversions of 30 degrees and 45 degrees.